Welcome to Independent Aircraft Investigations. My name is Richard Godfrey. Today we are going to investigate MH370 and the US and Australian defence facilities supporting radar, signals intelligence, and space-based surveillance in the broader Indian Ocean region. JORN, JDFPG, and NSF Diego Garcia. How did MH370 disappear into the Indian Ocean? How is it possible for an aircraft like a Boeing 777 to simply disappear? In the modern global glasshouse of radar and satellite systems, surely someone must have tracked the aircraft. Questions have been raised regarding potential detection by over-the-horizon radar, underwater acoustic systems, and military radar installations. A lot of questions and very few answers. Independent Aircraft Investigations brings you the established facts. We provide traceability of all evidence to a source authority. We make a clear distinction between factual data and analytical interpretation. We operationalise ICAO Annex 13 by embedding investigative discipline directly into the production of each episode. This ensures factual material, analytical work and narrative outputs remain clearly distinguished, traceable, and compliant throughout the life cycle of an investigation. Aviation news is covered on daily airline news as it happens. This channel is reserved exclusively for in-depth investigations. If you find this analysis useful and want to see future independent investigations, subscribing to the channel helps ensure this work continues. And some images and animations in this program are computer-generated or stock visuals used for illustration only. They do not represent the actual aircraft, the crew, or recorded flight data unless explicitly stated. And you will find the script for each episode we do, together with the illustrations and graphics used, as a downloadable PDF on my website, mh370search.com, under the tab Archive. In the previous two episodes, Unexpected Diversion and Unforeseen Destination, we established that MH370 diverted from its flight plan and made an air turn back across Malaysia and headed out over the Malacca Strait in a northwesterly direction, and then eventually turned south over the Indian Ocean. The aircraft continued flying for a total of 7 hours, 37 minutes, until fuel exhaustion. The aircraft was unidentified following the diversion at 17:20:34 UTC until 18:25:27 UTC, when the Satellite Data Unit, the SDU, was rebooted, and the ICAO identifier hex code 75008F for the Malaysian Airlines Boeing 777-200ER registration 9M MRO was received via the Indian Ocean Region Inmarsat satellite 3F1 and at a ground station in Perth, Australia. The aircraft remained unresponsive and there was no radar contact. Satellite phone calls and messages sent to the cockpit printer went unanswered. the standard ICAO procedure for an unidentified and unresponsive aircraft was not followed. In this episode, we will examine the roles and theoretical electronic surveillance capabilities of the Jindalu Operational Radar Network, JORN, the Joint Defense Facility at Pine Gap, JDFPG, and the Naval Support Facility, Diego Garcia, NSFDG. We will provide an overview of the US and Australian defense surveillance systems with relevance to the Indian Ocean region. The Australian and United States governments have made no public statement confirming or denying the detection or tracking of MH370 by these facilities, which are based in both mainland Australia and at Diego Garcia. And they support a range of maritime, airborne, space-based, and undersea surveillance functions. JORN is the Jindalu Operational Radar Network, which is an over-the-horizon radar system run by the Royal Australian Air Force. JDFPG is the Joint Defence Facility Pine Gap, which is jointly run by Australia and the United States. It is operated by the Australian Signals Directorate, the ASD, on the Australian side, and the National Security Agency, NSA, on the US side, with additional involvement from the Central Intelligence Agency, CIA. NSFDG is the Naval Support Facility Diego Garcia, which is run by the US Navy Indo-Pacific Command. The UK retains sovereignty through the British Indian Ocean Territory, BIOT, but that's only de facto, and it is disputed legally. Mauritius claims sovereignty, and the UN voted overwhelmingly in support of Mauritius. The US operates under a long-term UK-US defense agreement. Day-to-day command and base operations are entirely US Navy-led, with substantial joint and rotational presence from United States Air Force and other US forces as required. So in summary, JORN is a HF over-the-horizon radar, an OTHR, and its surveillance is active radar, both air and maritime. Pine Gap is a satellite and signals intelligence support, a SIGINT station, and its surveillance type is space-based infrared IR SIGINT. And Diego Garcia is a comprehensive intelligence, surveillance, reconnaissance, and ISR station. It uses radar, space tracking, and various ISR support systems. From the website www.airforce.gov.au, the frequently asked questions page, the question is answered: did the Jindalu Operational Radar Network, JORN, detect flight MH370? The answer given is Malaysia Airlines flight MH370, a Boeing 777-200, was classified as missing at 0240 hours on the 8th of March 14, whilst en route from Kuala Lumpur to Beijing. On the 24th of March 14, the Malaysian Prime Minister announced that MH370 had probably ended its flight in the middle of the Indian Ocean to the west of Perth, far from any possible landing sites. The aircraft was carrying 227 passengers and 12 crew, including 6 Australians. And it continues, based on the time of day that MH370 disappeared, and in the context of peacetime tasking, JORN was not operational at the time of the aircraft's disappearance. Given range from individual over-the-horizon radars, the ionospheric conditions, and a lack of information on MH370's possible flight path towards Australia, it is unlikely that MH370 would have been detected if the system had been operational. End of the quote. In my view, it is technically and operationally plausible that JORN as a network was not operating. By that I mean not radiating or not crewed or not tasked during the MH370 disappearance window, even if the physical sites and arrays existed and were fully functional. Very little activity of strategic or military significance occurs in the Indian Ocean without some likelihood of being detected by the US, Australia, the UK, and their partners, though detection does not always equal disclosure or response. This awareness is enabled by Five Eyes intelligence sharing between the US, the UK, Australia, Canada, and New Zealand. NATO maritime domain awareness and close coordination with India, Japan, France, and regional navies is also very helpful. The assessment refers to probabilistic detection of strategically significant activity and should not be interpreted as asserting total visibility, persistent real-time tracking, or any predetermined operational response. The United States, China, Russia, United Kingdom, France, Israel, India, Japan, and South Korea are able to claim as a matter of defense posture a degree of continuous defense of their sovereignty based on a combination of national military capability, deterrence, and in some cases, alliance support. Canada, Australia, New Zealand, Germany, Italy, Spain, Finland, Sweden, and Norway do not claim an adequate, autonomous, continuous defense of their sovereignty, but instead explicitly rely on collective defense and integrated security arrangements, including NATO, NORAD, and intelligence sharing frameworks such as Five Eyes. At the first glance, the over-the-horizon radar coverage from Australia looks very large. But there is an important nuance. It is not an air traffic control radar system. The over-the-horizon radar achieves extreme range by bouncing HF radio waves off the ionosphere and accepting major compromises in precision. The signal intelligence coverage of the Indian Ocean region is complete. According to the Malaysian and Australian official reports, the only signals emitted by MH370 were Inmarsat satellite communications around every hour, and we already have all that data. The data stream contains the unique ICAO identifier hex code 75008F for 9M MRO in every header. The aircraft registration 9M MRO is the Boeing 777-200ER that operated flight MH370 on the 7th of March. JORN operates near 3 locations in Australia: Laverton in Western Australia, Alice Springs in the Northern Territory, and Longreach in Queensland. At each location, there are 2 sites between 82 kilometres and 119 kilometres apart, one with the transmitter antenna array and the other with the receiver antenna array. For example, Alice Springs is pointing in a northwesterly direction over the Timor Sea toward Indonesia. JORN can detect and track aircraft taking off from Changi Airport in Singapore. JORN works just like Whisper, using HF ionospheric transmissions, typically in the range 3 MHz to 30 MHz. Unfortunately, on the evening of the 7th and 8th of March 2014, we had optimal ionospheric conditions. JORN has a frequency management system to find the optimum frequency for each task. There are 15 antenna arrays in total. The transmitter antenna array is relatively compact. For example, at Alice Springs transmitter site in the Harts Range, which is 99.5 kilometers northeast of Alice Springs, there are 2 antenna arrays. One is 106 meters long and the other is 92 meters long. The receiver antenna array, however, is massive. The Alice Springs receiver site at Mount Everard, which is 28 kilometers southwest of Alice Springs, has a continuous line of antennas 2.765 kilometers. That's 1.72 miles, and comprises almost 1,000 dipoles in 2 rows. The large number of dipoles allows fine control of the received beam direction through phased array processing. A very long aperture dramatically improves sensitivity to weak skywave returns from targets which can be thousands of kilometers away. The Laverton and Longreach receiver antenna arrays are even longer, close to 3 kilometers. At Laverton, there are 2, and they're placed 90 degrees to each other and covering different directions. We mentioned that aircraft can be seen taking off from Singapore. How does JORN in Australia watch aircraft in Singapore over a distance of 4,231 kilometers? We will now explain how this is possible and how it is possible for JORN to detect and track MH370 with certain limitations. MH370's estimated position at 18:28:15 UTC when the SDU was rebooted, and this is according to the Boeing report as part of the Malaysian official report, was at 6.676 degrees north, 95.492 degrees east, at the northern tip of Sumatra in Indonesia. From Alice Springs receiver, the distance is 5,328.2 kilometers on a bearing of 304.0736 degrees true. Let me explain why it is difficult for JORN to detect MH370 at this point in time at 1828.15 UTC over a distance from Alice Springs transmitter of 5,365 kilometers, even at night when radio signals travel further. JORN uses ionospheric propagation. At night, radio waves are bounced off the upper layer of the ionosphere called the F layer. We're showing the trace of a radio wave at 16 megahertz with an angle of elevation of 6.9 degrees. In 2 hops, the radio wave reaches the target and bounces back. The first hop reaches an altitude of 295 kilometers, and the second hop 235 kilometers above the Earth's surface. We know from a computer model of the ionosphere the maximum usable frequency was 16 megahertz, and the corresponding elevation angle was 6.9 degrees. The reason that this may not have worked is the interim landing point between the 2 hops was not the relatively flat sea, but the town of Semanding on the north coast of East Java, Indonesia. And this could deflect or absorb the radio signals just at the wrong point in time. But later on in the flight of MH370, for example, at 2100 UTC on the 7th of March, the MH370 estimated position from the WHISPER data is 7.88 degrees south, 94.46 degrees east. This is between the third arc at 2041.05 UTC and the fourth arc at 2141.27 UTC, based on the Inmarsat satellite data. At 2100 UTC, 0630 AM local time in Alice Springs, MH370 is within the coverage of JORN. This does not mean that JORN was targeted to look for MH370. It only means MH370 was within range. The distance between JORN Alice Springs transmitter and the estimated position of MH370 is 4,581 kilometers. Not only were the ionospheric conditions ideal, but the transmitter was located on the so-called grey line at dawn, which enhances radio propagation. Again, a 2-hop ionospheric propagation, but this time at 10 megahertz and at an elevation angle of 11.4 degrees would work, and the interim landing point would be on the surface of the Indian Ocean and not in a town in Java. And this has much less scatter and clutter than the town in Java. Now, of course, both ground clutter and sea clutter can affect JORN, and in fundamentally different ways. Ground clutter requires Doppler rejection, clutter maps, and spatial nulling. Sea clutter requires Doppler separation, long integration, and adaptive constant false alarm rates. Both require bistatic Doppler geometry exploitation. JORN is affected by both ground clutter and sea clutter, The two arise from fundamentally different physical mechanisms and statistical behaviors. And while both are suppressible through signal processing, neither is the primary performance limiter when compared with the ionospheric variability. In summary, the key analytical conclusions, and I've tied them down to UTC timing, is the ICAO-defined aviation distress phase, the DETRESFA, was pronounced at 22:32 UTC on the 7th of March. And that is the only authoritative SAR, search and rescue, trigger relevant to the Australian involvement. The timestamp of 0240 cited in the RAAF public material must be UTC, as any local time interpretation precedes the aircraft's departure and is therefore invalid. By 0240 UTC, MH370 had already exhausted fuel and ceased to exist as an airborne object. Consequently, no post-0240 UTC detection tasking could have detected MH370. Any assessment of missed detections must be bounded strictly between 22:32 UTC and around 0019 UTC, a window of less than 2 hours after which detection is physically impossible. The conclusion that I draw is that at 22:32 UTC on the 7th of March, Malaysia Airlines flight MH370 was still airborne and within the potential coverage of Jindalu operational radar network, at least the Laverton West sector, and was therefore geometrically and physically detectable if, and only if, the system had been explicitly tasked and correctly tuned at that time and throughout the following approximately 1 hour and 55 minutes of the continued flight. The question is whether there is data available that tracked MH370 at that point in time and for that duration. On the next episode, we're going to go into more depth on this. On the 28th of January, together with Jeffrey Thomas, I plan a joint episode on what Captain Martin Smith observed. He was an Emirates captain on a flight over the Indian Ocean the day after the disappearance of MH370. And we're going to go into the US Poseidon P-8A involved in the surface search for MH370. On the 30th of January, the next episode on this channel, we will go into more detail of the capability of Pine Gap, the JDFPG, and the Naval Support Facility Diego Garcia, NSFDG. So please leave any comments or questions. We will address the key points in the next episode and publish responses on YouTube and our website, mh370search.com. Thank you very much for watching, and please subscribe for future investigations.